We're going to look a little bit into the powers of I. Yesterday we did some addition and subtraction. Today we're going to look at powers, multiplication, and division of complex numbers. To start with, we're just going to investigate powers of I. So yesterday we defined the imaginary unit I as the square root of -1. So I to the first is obviously just I, but I squared would be the square root of -1 squared. And what would happen with the square and the square root? They would cancel. So I squared would really have a value of -1. Now, so now I know what I to the first is. It's just I, and I know I squared is -1, and I cubed is my next one, but I cubed could be written as I squared times I, right? Because 1 plus 2 is 3. So I squared is -1, and I is just I, so I cubed would be -I. So I to the first is I squared is -1, I cubed is I to the fourth could be written as I squared times I squared, which is -1 times -1, which is 1.
Can everything have I to the fourth? Can everything we do have I to the fourth?
Oh, wouldn't that be nice? Okay, I to the fifth. Could I think of this as I to the fourth times I? And I to the fourth is 1, and I is I. So I to the first is I squared is -1, I cubed is I to the fourth is 1, I to the fifth is I to the sixth. Let's do this times this, maybe, which is 1 times -1. Ooh.
That's amazing.
Ooh.
It's a pattern.
Sophia already knew.
There's a pattern.
Okay? You see a pattern. So this is I to the fourth times I cubed, right? Do you see how every time I'm using I to the fourth, I stuck with I to the fourth because I to the fourth is 1. So this is 1 times -I, which is -I. What's the answer to I to the 8th? 1. Because it's I to the fourth times I to the fourth, which is 1 times 1, which is what? 1. Okay, so what would I to the 9th be? I to the 10th. -1. I to the 11th. I to the 12th. I to the 13th. I. Okay, so it repeats. This pattern repeats over and over and over again. I to the first is I squared is -1. I cubed is I to the fourth is 1. And it's a pattern that repeats. Yes, sir?
What if you did like the four, I think this is the fourth root of I, so like the 4 and then the root and then I.
That's different. And we're not talking about that yet.
Yeah, Joe, so I'm trying to confuse. Can you go back?
Yes.
What if we got I to the 374th? Is that
Oh,
possible?
actually, we're about to do that.
Bruh.
I like it. You picked I to the 374th. I to the 374th. We can use the fact that this pattern repeats. And I'm going to start with one that's a lot easier. Like, let's dissect I to the 11th real quick. Could I think of this as I to the fourth times I to the fourth times I to the third? Okay? So really, because this pattern repeats every 4, if we look at this exponent and divide it by 4, it goes in there twice. So that tells me it goes through the pattern completely 2 times. And then how many are left over? 3. So I to the 11th is equivalent to I to the third, which is -I. I to the 37th, it would go through the pattern completely 9 times, which is 36.
It's all right.
So then it would have 1 more, so it would be I. Okay? I to the 83rd. We'd go through the pattern completely 20 times. With how many left over? 3. So that's negative I.
Wait, how would it go through 12? Wait.
Okay, so what you do, basically what we're doing is we're saying, let's take the exponent,
Oh, okay.
take the exponent and divide by 4.
Okay.
Because that's how many times it takes before it goes completely through the pattern. But what we're looking at is the remainder. What we want from this is the remainder. Okay, so it goes through there completely, 83 divided by 4, goes through there completely 20 times. We don't care about that. We care about what's left, the 3.
Leftovers.
Okay? So, Carson said I did the 374th power.
Why do you say that?
Well, because it's a good number. It's a good number. Now, some of us can do this in our head. Some of us might need to sketch it out real quick. We're divided by 4, not by 3. Where's that crazy number come from? So we'd say this goes in there 9 times, 36, 14, 3. But what we care about is the remainder, and the remainder is 2. So this is equivalent to I squared, which is negative 1.
That's gorgeous.
Okay? So, some of us are going to see this once and we'll know this pattern forever. Others of us, our brains don't work that way. So, Ms. Fuller, I have to give her credit because this is not me. She came up with a memory device for the powers of I, and it has a little story with it. On the way home, she bought a lotto ticket. She got home that night, she thought about it, she checked the numbers. Guess what? She looked at the ticket. She looked at the numbers, they matched. And she went, I won! I won! I won. I won. And the 2 in the middle are negative. So her mnemonic device is I won, I won, and then 2 in the middle are negative. Okay? So she has her students write this at the top of their page, and if they need to help remembering, they go to that little story.
Did that actually happen?
No.
Did she actually win the lottery?
She would be teaching.
You could win a small lottery and still work. My dad won Fantasy 5, won $55,000. That's not enough to retire. But it was enough to get the house re-roofed.
Usually the lottery.
That extravagant man.
But who's yeah. Well, you also thought.
Okay. So, what we're going to do is we're going to use the powers of I to help us simplify when we multiply. So, it was critical that we investigated the powers of I first because we need to have an understanding of that to be able to simplify when we multiply. So here we just multiply, we're going to distribute, and when we do, we get 6I minus 2I squared. But now we know the value of I squared. I squared is negative 1. And when we multiply by negative 1, it's just going to change the sign. So it becomes 6I plus 2. Now, because I know, and you know, that multiplying by negative 1 just changes the sign, we could just take a shortcut and go and change the sign. Because multiplying by negative 1 just changes the sign. Now, this is not my answer. Because when I deal with complex numbers, I always write the answer in A plus BI form.
So it's 2
So
plus
the
6i.
answer would be 2 plus 6I. Yes, it
Always
would.
write it in that form.
Always write it with the real part first, the imaginary part second. That is the form for a complex number.
Because big things come last.
What thing?
Oh, I like it.
Big things come last.
Okay, so here we go. We're going to multiply this complex number times this complex number. So really, it's just distributed. So we're going to distribute the 5 through, and then the negative 1 through. So we distribute the 5 through and we get 10 plus 20I. Distribute the negative I through and we get negative 2I minus 4I I squared. But what is the value of I squared? -1. So it changes this -4 to a +4. Then we put the real parts together. 10 plus 4 is 14. We combine our imaginary parts, and we get plus 18i.
I got it right.
Okay, the next thing we're going to do is square a complex number. So, just like before, when we squared a binomial, you can square the first, double the product, and square the last. So if we square the first, we get 9. If we double the product, we get -30i. And when we square the last, we get a positive 25i squared. Okay, so remember, we squared the first, we doubled the product, and then we squared the last. And remember how that relates to Pascal's? It's 2, so it's 1, 2, 1. That's why we double, right? 1, 2, 1 on the triangle. You with me?
Oh, I'm with the other way.
Okay, cool. All right, now, this I squared makes this a negative 25. So in simplified form, this would be -16 minus 30i.
Hey, bro, how about you?
Hey.
Yep.
Oh, they go. Psych.
All right. Now, let's do a combo. A little powers with a little multiplying with a little addition.
And more powers.
Okay? Now, if I were you, I would simplify the powers first. Because if I can simplify this, when I distribute it, it gets easier. So, I to the 7 is the same as I cubed, which is -i. So this becomes -3i. Okay? Let's work on my next power. I cubed is -i. So that becomes a positive 5i. I squared is -1. So that would be -1. So it's going to change the signs.
It looks so much prettier.
Yeah.
I like that.
So dealing with the powers first is helpful. I mean, you could distribute, and it's still going to work out to be the same. It'll just be more work. Now we're going to distribute and distribute. So we get -6i
Wait, you don't have to change
minus 15i squared minus 4 plus 1i. 1i. All right, so this I squared right here is like multiplying by -1. So we get 11 minus 5i when we combine like terms. On the U try. Now you try, the U try.
Wait. Oh, I to the 11. Quotation marks. What is going on?
I did for a quick second, honestly.
You tries.
Into its 70s.
Next on my. Yeah. There's two left over. No,
So, we divide by, wait, so it's on. Wait, so when you taking the, wait, so when you're trying to change
I negative
simplify, you would take
Yeah.
the
It's negative 1.
exponent divided by 4, and then the remainder would be your new exponent.
Correct.
Okay.
It's so pretty. Wow.
It is, because it's out of the book again. So, since I've collected most of the books,
Who's gonna change the time?
next year I'm gonna make a note to myself to not collect the books until after this week. It'll be good. Speaking of books, if you still have yours,
This will be my next part of that, just not able to say think goodbye, because I'm gonna forget it in my head.
5 plus.
I bet you can remember.
Yeah.
If you take your phone out right now.
Yeah, I'm about to put it in right now.
Okay.
Gotta change the time.
Noah, have you given me your textbook?
Yes. Yeah, I give it to you.
I did
No,
not.
I give it to you on Wednesday.
I mean, mine
You
said.
gave it to me sometime.
Yeah.
I did not highlight it when you gave
Oh,
it to me.
well.
This is next.
I got it. Jimmy, have you given me your book?
It's in my locker.
Alright. If we have extra time at the end of class, I want you to run and go get that. Ty, is yours in your locker or is it mine? Okay. I did the 11. The remainder is 3 when I divide by 4. So it's I cubed, which is negative I. I is 74. Okay, so you might not be able to do that really easy in your head, but you know that 4 goes into 80 evenly, and this is 6 away, so the remainder's got to be 2.
I do.
Because 6 divided by 4, the remainder is 2. Good. So this is the same as I squared. Okay? And I squared is negative 1. So it's like multiplying by negative 1, so it becomes a positive 2.
Positive 2i or just positive?
Just positive 2.
I understood.
I like completely
I messed up with, I put I instead of negative I.
Okay?
I don't know.
So you could do it like that and say the negative 2 is right here and say I squared does that.
Okay, so I messed up.
Okay? So then we're going to distribute here.
I did.
And then weird things happen because that cancels.
I did
That
everything
turns
right.
into negative 7. And my answer is 5. So I really thought about writing on the board pi and then that.
That's not.
Oh my god, Miss Wilby, I was like totally freaking out because I thought I did
Pretty much
like
got it
completely
right,
wrong.
Because you got
I
5?
was like, I got 5 and I was
It's awesome.
like,
If
and I was
I
like,
literally just did negative I did everything right and I would have got
Isn't it awesome? Yeah.
I pretty much
You're
got it
also
right,
making
Miss
people
Wilby. So,
understand.
yeah, Julian's in it.
Take my word for it.
You just got I.
I got 12.
Okay. Division.
I didn't do it.
Now, we can't treat this like we do polynomials division. Because this is not. I represents the radical, square root of negative 1. So when we have division by a complex or an imaginary number, we really have to treat it like we're dealing with radicals. And our rules for radicals say you can't have radicals in the denominator.
You can.
Which means we cannot have I in the denominator. Okay?
Imaginary, just.
And so we have to multiply by what?
I.
We do!
So
Julian, did you hear that?
We
I
do!
over it. I said it.
And not only I, we have to multiply by I over I because we can't change the value. We just change the form. So when we multiply by something over itself, it's really multiplying by a value of 1. But magic things happen. Now, yesterday we actually talked about a conjugate. And instead of multiplying by I would like to multiply by negative I. Why?
Oh, so
Because
it's
what is the value of negative I squared?
1.
Positive 1. Okay? So, negative I squared is going to give us that positive 1 in the denominator. We want the denominator to be positive. We would never leave a fraction with a negative denominator. So, it's best to multiply by its conjugate. So, negative I. So, up top, we're going to distribute that. And we'll get negative 4 plus 7I squared. But what is the value of I squared?
Negative 1.
Negative 1, so that changes that. That should be an I right here. Woo! Close one. That was confusing. That's why you were confused. So this becomes 4I minus, I did again, I just don't like that one. And this negative I squared, we said I squared is negative 1, and minus a negative makes a positive 1.
And so it's 4I.
And so the answer is
Negative
just
7.
negative 7 minus 4I. Okay, so if we just have an imaginary number in the denominator, the best thing to do is multiply by negative I over negative I. Because that does the trick. So if we just have an imaginary, multiplying by negative I over negative I will eliminate the imaginary number from the denominator. So when we do that, we get negative 3I minus I squared over negative 2I squared. Okay, I squared is negative 1, so in this case it makes it a positive 2. I squared is negative 1, so minus a negative 1 makes it a plus 1. Minus a negative 1 makes it a plus 1. So this simplifies to 1 minus 3I over 2. Now, I have to be a little upfront with you. Those of you that go home every day and research the math we talk about in here, which I'm sure is many, many, many of you. You investigate further, you make sure what I tell you is truthful, those kind of things. We'll find
This is a student really like she's lying.
That-
I know it.
that many people will force you to write the answer like this.
Why?
Why? Because we require our answers, our complex answers, to be in A plus BI form, where the real part is separate from the imaginary part. And when we write it as a single fraction, we don't really see that.
Oh well.
Okay? But over the last 10 years, I have noticed more and more publications. I've even seen it on the standardized test where they left the answer like this. I need you to understand that these are equivalent. And I need you to be okay if you leave my classroom and another teacher or one day professor requires you to write it like this. I need you to understand why. But I will accept either. Because either forms are becoming more commonly accepted. Okay. So, yeah.
It's not that I didn't get it.
Okay, so with this one, it's not just an imaginary number in the denominator, it's actually complex. It has a real part and it has an imaginary part. And this is where the conjugate really comes into play. Because when we multiply by the conjugate of the denominator, it eliminates any imaginary part from the denominator. Watch. When we distribute 2 times 2, 4. 2 times I, 2I. Negative I times 2, negative 2I. Negative I times I, negative I squared. I squared is negative 1. So it ends up being plus, because those cancel. Anytime we multiply a complex number times its conjugate, the imaginary parts cancel. It's kind of like the opposite of a difference of squares. Y'all remember how a difference of squares is just a squared minus b squared, but when you factor it, it's a plus b times a minus b. So when we multiply that back, it makes the imaginary parts vanish. And the denominator is just a real number. 5. Yes, ma'am?
I thought the 1 was negative.
It was, but it was minus a negative 1. So I squared is negative 1. So if I plug in negative 1 where the I squared was, I get minus a negative, which makes a plus. Okay? Numerator, I just have to distribute. And I get 6 plus 3i plus 2i plus I squared. And I squared, once again, is negative 1. So I get 6 minus 1 is 5. And 3i plus 2i is 5i. Now, if I think about this form, we can clearly see that everything simplifies.
So it'll be 1 plus 1 9.
And that is the only acceptable answer. When it simplifies, we must. So if you can see it here without splitting it, go for it. But if you can't, split it and then simplify. All right, you try.
Gotcha.
How do you get the minus 20? Oh, you should not.
30. Yes, I got it. Oh, we go even further?
I need to simplify.
Oh, hold on.
Hey,
Oh, divide by
so I told you I would accept either. This is the simplest when it's written as a single fraction. This is the simplest when we split it.
Did you? Oh. I see what you mean.
We need to recognize they mean the same thing. So if I gave you a multiple choice,
Got it.
and this was one of the answers, that one would be the right one. So you need to know that this means that. Okay?
But it's the only one is right.
Yep. If I gave you that one. All right. So your homework is out of the textbook. It's not what's written on the board because I forgot to correct the board, but it is what's on the calendar. It's also what's printed at the top of the page you picked up today. Because I have collected your geometry textbooks, I went ahead and printed out the work for you. Okay, so it's not all the problems, because when I snipped, I got some extra in that middle section. So look at the problem numbers. Just make sure you do the assigned ones.
109.
And that's what's due tomorrow.
What's 109? We don't have 109.